Hey everybody, happy Friday. So here is your answer key for the homework that you had for last night. I wanted to make sure you were able to see this before your quiz on Monday. If we go through any of this too fast, it'll be available on Moodle, or you can come up and see me Monday morning and we can go over it. So number one was kind of a tricky one to get a counterexample. Adjacent means that they're right next to each other. However, if we draw overlapping angles, then they're not adjacent. So we can draw two angles that have the same vertex, have a common side, but they're actually overlapping, which would cause them not to be adjacent. Similar is number 5. If you draw R in the middle of ET, it ends up being that the segment RT is overlapping with segment ET. So now ER is actually 3 instead of 13. So that would be another counterexample. Here is the rest of your answer key. So again, if you need to look at that any further, it will be on Moodle. Here is our review problem. So we had to practice writing out our statements. This time, the first one they gave us was the converse, and we know that that is if Q, then P. So to go back to the conditional, we have to switch it back. So this would be if X is greater than or equal to Y, then X squared is greater than or equal to Y squared. Now we have our conditional, so we can now go to the inverse. So the inverse is negation. So taking the original conditional and negating it. Remember, the inequalities, the negation of greater than or equal to is less than. So if X is less than Y, then X squared is less than Y squared. The contrapositive is to switch and negate the original conditional, but if we already have the inverse, we've already negated it, so now we could just switch the inverse. So this would be if X squared is less than Y squared, then X is less than Y. Your biconditional has two options. So the first could be X is greater than or equal to Y if and only if X squared is greater than or equal to Y squared. Or we can switch it and say X squared greater than or equal to Y squared if and only if X is greater than or equal to Y. Now, as far as these being true or false, if we're saying they're false, we need counterexamples. So for the conditional, I believe this is false, and here is my counterexample. What if X is 1 and Y is negative 7? So X is greater than or equal to Y because 1 is greater than or equal to 7. But if I squared them, I would get 1 and 49. And 49 is obviously bigger. So that would be my counterexample for number 1. The converse is also false. What if X is negative 3 and Y is negative 2? So in this case, X squared would be 9 and Y squared would be 4. So it does satisfy my hypothesis, but X being negative 3 is actually smaller than Y, which is negative 2. So that would be a great counterexample. Now the inverse is also false for the same counterexample as my converse, and the contrapositive is false for the same counterexample as the conditional. So all of these are false. And as far as the biconditional goes, remember you're checking conditional and converse. Since they are both false, this biconditional is also false. All right. Here are our notes for today. Now the focus of today is justifying true statements. So we focused a lot on counterexamples with false statements, but now we're looking at conditionals for true statements. So all of these conditionals are true, and we have to come up with the definition, theorem, or postulate that justifies why these are all true. So number one, if the measure of angle 1 is less than 90, then angle 1 is acute. So how do we know that angle 1 is acute if it's less than 90? The definition of acute angles told us. Because the definition is that an angle that's acute is less than 90. Number two, if two angles form a linear pair, then they are supplementary. This is true because of the linear pair postulate. This is not the definition, this is the postulate. The postulate is the one that tells us our linear pairs are supplementary. Number three, if M is the midpoint of KO, then KM is congruent to MO. Well, the definition of midpoint is what tells us that it's a point in the middle creating two congruent segments. So whenever you see two congruent segments with a midpoint, that's going to be your definition of midpoint. Number four, if angle 1 is congruent to angle 2, then segment KW bisects angle NKO. This is definition of angle bisector because we know that if we have an angle bisector, we get congruent angles. Number five, if segment WK bisects segment PO, then KP is congruent to KO. There are technically two really great answers for this one. We have a segment being bisected. So we're talking about a segment bisector. So if you say definition of segment bisector, that is a great answer. However, if you remember when we talked about segment bisectors, our very first thought is a midpoint. So technically, this is also the definition of midpoint. If this was a test or quiz, I would take either answer. Now, number 6. Segment KN is between KP and KW. So that means angle 1 plus angle 2 equals angle PKW. When you see the word between, you should be thinking segment betweenness or angle betweenness. And if you look, we're actually talking about angles, adding two angles that are next to each other to create the whole big angle. So this is definition of angle betweenness. Number 7, if two lines are perpendicular, then they intersect to form right angles. We know this because that's the definition of perpendicular lines. So if we have perpendicular lines, we know they create right angles. Number 8, we're talking about two segments being added that are next to each other to equal the whole big segment. And then it says K is between P and M. So hopefully the word between made you think of segment betweenness or angle betweenness. And we're looking at segments being added together. So this is definition of segment betweenness. Number 9. If M is the midpoint of KO, then 2 times KM equals KO. This is not definition of midpoint. Definition of midpoint was like number 3. They gave us the congruent segments because of the midpoint. This is the midpoint theorem because we are taking 2 times the smaller segment to be the bigger one. So anytime we do 2 times the smaller segment to equal the larger one, or half of the larger segment to equal a smaller one, that is the theorem, the midpoint theorem. Now, number 10 says that KW bisects an angle NKO. So angle 1 is half of angle NKO. So we're obviously talking about an angle bisector, but this is not the definition because we are taking half of the larger to get the smaller. So it works exactly the same as we just looked at it for midpoint. It's just an angle bisector instead. So this is the angle bisector theorem. Now the last one, if angle 1 is obtuse, then the measure of angle 1 is greater than 90. This is definition of obtuse angles. Good. So the other paper that you have lists a bunch of theorems and definitions and rules that we've already had this year, and they're listed by chapter. Most of these are in our notes. There is one more that I want you to add. So in chapter 1, you want to add definition of congruent segments to the list because that one's missing. So for chapter 1, you want to add definition of congruent segments to the list. This gives you a nice list to refer to when you're doing your justifications to help you out. Think of it like a word bank. But keep in mind that this list cannot be used on tests and quizzes. So eventually you want to get to a point where you've practiced enough with this list that you can think of your justifications without it. So that is the goal. There are a couple of these that have very small differences, but those differences are important. So I'm highlighting some of them here. So the difference between the definition of a linear pair and the linear pair postulate. The definition is just a visual way to understand that we're looking at a linear pair. So they are 2 angles that are next to each other and they form a line. That's the definition. I can look at this and say this is a linear pair. As soon as I start talking about the linear pair being supplementary, that is when it's the linear pair postulate. So as soon as I start putting angle measures in here, and I can say, oh, the other angle is 80 degrees because it's a linear pair. Getting this answer is the linear pair postulate. I starred the postulate because most of the time we're using the postulate. We won't use the definition much for our justifications. So when in doubt, use the postulate. Now, definition of vertical angles versus vertical angles are congruent. The definition is that I have 2 intersecting lines and the opposite angles that are created are vertical angles. So visually, I can look at this picture and say those are vertical angles. When we start to say that those angles are congruent, so as soon as I put those tick marks on there, now I used the phrase vertical angles are congruent. So I also starred this one because we're going to use vertical angles are congruent more than the definition of vertical angles. So when in doubt, use vertical angles are congruent. The definition of a right angle versus right angles are congruent. If I tell you that the measure of angle 1 is 90 degrees, that is the definition of a right angle because the definition says that a right angle is 90 degrees. If I list 2 angles, so let's say I have a picture, and this is A, B, C, D, and I know that they're both right angles. if I say, let's make this angle 1 and angle 2. If I say angle 1 is congruent to angle 2, and you notice that they're both right angles, then we use the phrase, all right angles are congruent. Okay, so there's the difference between those two. We talked about the definition of midpoint versus midpoint theorem and the definition of angle bisector versus angle bisector theorem. So these work the same way, it's just a midpoint versus an angle bisector. So if you're using midpoint, make sure we're talking about segments. If you're using angle bisector, make sure we're talking about angles. If you notice that there's a midpoint and it's just two segments congruent to each other, that would be the definition. If you notice that we are taking like 2 times the smaller segment to equal the bigger segment, or 1/2 of the bigger to get the smaller, that's the theorem. Same would go for an angle. If you notice that the angles are congruent because of the angle bisector, that would be the definition. Or if it's 2 times the smaller to equal the bigger, or 1/2 the bigger angle to get the smaller angle, that would be your theorem. All right, so on your homework assignment, I just want to help you get started. This picture will be used a lot more for this homework than it was in our notes. So all of this given information, you want to mark the picture. So for example, the first piece of given information, RK is perpendicular to AL. I want to go to the picture and I want to mark that. So that means I have a right angle right there in the picture. Make sure you mark the rest of them because they will help you with your justifications. So for number 1, where it says angle ARK is a right angle, that's the right angle I just marked. So as you go through these questions, always ask yourself why, or how did I know that? How did I know that angle ARK is a right angle? Well, it's because of this piece of given information right there, the perpendicular lines. So this is definition of perpendicular lines. It is not definition of right angle. Now part B is saying, hey, angle ARK is 90 degrees. Why is it 90 degrees? Because of the definition of right angles. So if you're feeling confused, definitely look at the list of definitions and theorems that you have. You can also go back in chapter 1. This is where chapter 1 vocab is very important. So if you need to brush up on those, definitely go back and look at your notes for chapter 1. So remember, as you are answering this question, answering these justification questions, after each statement, ask yourself why or how do I know that? Because it might have come from the given information. So make sure you go through all the given information and then ask yourself why. All right, if you have any questions, feel free to come up on Monday morning and I can help you out. Also, don't forget that you have a quiz on Monday, sections 3.1 to 3.3. So that does not include the justifications from today. All right, guys, I hope you have an awesome weekend. See you Monday.